The Model Context Protocol, or MCP, has changed how LLMs access the real-world data. So it has revolutionized LLM data access. But running an MCP server locally is just step one, right? So there's a massive gap between a simple local setup and a robust production-ready implementation, right? So to bridge that gap, we need a strategy for secure and scalable hosting. In this session, we're going to take a look at a sample MCP server written in Python and deploy that onto Google Cloud Run and lock it down so that it requires authentication, and then configure Gemini CLI to securely talk to it and conduct a few tests. Okay, so we aren't simply opening MCP server to the world, we are doing it securely using IAM authentication. Okay, so let's dive in. All right, let's take a look at the architecture here and quickly define our building blocks. First, we have an MCP server here, which is a standardized backend service that gives LLMs access to external tools and services such as a database or an API. So in this demo, it exposes a specific tool, a currency converter API, which LLMs can call to get access to real-time exchange rates. And next, we have Cloud Run, which is a fully managed serverless container platform offered by GCP, which you can use to run your containerized applications. And Cloud Run is a perfect choice for the MCP server here as a secure and scalable platform. It offers a built-in HTTPS, and it scales up the services to meet the incoming traffic demand and scales down to 0 instances to save the cost. And it has built-in integration with Cloud IAM for securing the services. And next we have Gemini CLI here, which is a command line developer tool that lets you interact with Gemini models directly from your terminal. So in this architecture, Gemini CLI is acting as a client application to the MCP server here. So we're going to make a secure authenticated call to the MCP server from Gemini CLI to test the tools here. Now let's take a look at the end-to-end flow step by step here. The first step is the deployment of MCP server on Cloud Run. So we use a simple gcloud command to push the containerized MCP server directly onto Cloud Run. So this gcloud command, it builds the container image for the MCP server, and it pushes that to Cloud Run platform, enabling the IAM authentication. And so we pass a few options to gcloud run command to perform this operation, which we'll take a look at during the deployment time. Now, to access the MCP server, we'll integrate that with Gemini CLI and conduct a few tests. So for that, we need to generate a token. Since the MCP server, which is deployed on Cloud Run, has authentication enabled, we'll need to submit a token, part of the request that we're sending to Cloud Run service to get authenticated. So for this, we'll use a gcloud command to generate a token, which will be a short-lived IAM token. So to submit this command, we'll need to grant ourselves, like our user ID, the Cloud Run service invoker role, and then using the gcloud command, we'll generate a short-lived IAM token, and then we'll save that into this ID token environment variable. Now for the integration, we'll update the settings.json of Gemini CLI, and we'll provide the MCP server Cloud Run service endpoint, and we will use this ID token environment variable for the authorization headers. And that finishes the integration here. Now when you test it, Gemini CLI makes a secure request carrying the token to the MCP server here, and Cloud IAM validates the identity before allowing the access to the service. And then the MCP server makes a tool call here, and the final response is received from the MCP server here. So that's how the end-to-end flow looks here, and now let's get into the demo. All right, here we are in the GCP console. We'll be deploying a sample MCP server onto Cloud Run platform. And for that, first of all, we need to acquire source code for a sample MCP server. So we'll be using Google ADK framework Python samples for that. So let's go take a look at those. So here we have a collection of sample agents in this Git repo. And we can see Python, Java, Golang samples within the Python and agents folder. We see several agents, and if we scroll down, here is the currency agent. And if we click on that, we see currency agent folder, which is the AI agent, and there is MCP server, and this is what the source code that we'll be using. And if you explore the source code, it's a simple Python server that uses the MCP library. If we go into this, we can see fast MCP is the framework that's used. And if we take a look at this server.py, we can see there is one tool that this MCP server is exposing, get exchange rate. It accepts 3 parameters here: currency from, currency to, and date. So currency from is the base currency, and currency to is the target currency, and currency date is the date that is considered for the exchange rate. And there are default options, the default values that are specified here. So it returns a dictionary containing the exchange rate data or an error message if it fails. We can see that's the definition of the tool there. And coming down here below, we can see that this tool is calling an external API. It's a public currency API that being used. We can clearly see that it is using the options that are being sent to the tool and coming back with a response. All right, at the bottom we can see that the MCP server is being started. And we're going to containerize this Python server. And for that, we have the Docker file here. We can see this is a standard Docker file that is installing the required dependencies and starting the server here. It uses Python base image, installs UV, and installing the dependencies and starting the server. And it exposes a port environment variable, which will be auto-injected by Cloud Run. Right now, let's get this code. We'll clone this repo. And coming back to the GCP console, let me activate the Cloud Shell. Okay, here we are. Git clone the repo. And we are going to have the ADK samples. There are several samples in that. We will be using the currency converter. We are in the currency agent folder, and here we have agent and MCP server. So we're getting into the MCP server directory, and that's where we are. All right. Right now, let's proceed towards the deployment. So we'll be using a few gcloud commands to perform the deployment. So to begin with, we are going to create a custom service account to be used by this Cloud Run service that we're going to deploy. The reason being, we don't want to use the default compute service account. It's a standard security practice to create a custom service account and use it with Cloud Run service. So let's create the service account. Here is the gcloud command to create the service account. So gcloud IAM service accounts create. This is the name of the service account, and that's the display name for the service account that's going to be created. All right, let's hit enter. Now we have the service account created. Let's go just refresh this. And here we can see the new service account that's being created. That's the full service account name that has been created. So we're going to use the service account in our next command. Or let's copy that. Or next, we're going to perform the deployment. So for that, we're going to use another gcloud command. So here's the command to perform the deployment. If you pay attention to the options that we're passing to the gcloud command here, it's gcloud run deploy, it's MCP currency server. This is the name of the Cloud Run service that we're going to deploy. We're saying the current directory. We are inside the MCP server directory where we have the Docker file, and we're indicating that that's the source directory. So it's going to use that Docker file to build the container image. And we're saying region. The service is supposed to be deployed in the US Central 1 region. And the service account, we're specifying the service account to be used by the Cloud Run service. This is exactly what we have created earlier. And then the last option we're saying here as no-allow-unauthenticated. This is basically locking down this Cloud Run service so that we require authentication when we try to access this MCP server. All right, let's hit enter. Now we can see that the command is progressing. It's building the container image. Okay, now it just finished building the container image, and now it's creating the revision that is performing the deployment onto Cloud Run. If you refresh here, now we can see that it's already deployed. You can see the name of the Cloud Run service. That's what we have given here. That's what is deployed, MCP currency server. And the US Central 1 was the region that we have picked, and we indicated that no-allow-unauthenticated, and that's what is specified here. Require authentication, that's the configuration that we chose. And if we click on this, we can take a look at the logs of this MCP server here, and there are metrics available as well. But now to access this service, this MCP server, this is the URL using which we were going to access the MCP server. So since this is locked down, if we simply try to curl on it, we should be getting a 403. Now the service is up and running, but no one can call it. The reason being, I'm missing the Cloud Run invoker role. So the point here is that whether it is a user account or a service account, if that's going to call this Cloud Run service, it is going to require the Cloud Run invoker IAM role. So let's grant that. So we need to grant the Cloud Run invoker IAM role to the user or the service account that will be calling it. So for this demo, it's going to be my user account. So I need to grant the Cloud Run invoker IAM role to my user account. Here is the gcloud command to grant the required role on the Cloud Run service. So we're specifying this is the Cloud Run service on which we're going to grant the Cloud Run invoker role to this user, and this is the region where our Cloud Run service is deployed. So let's hit enter, and now we have granted the required privilege. Now my user identity has permission to invoke this specific Google Cloud service. So next step for us is to create a token to submit as a part of the request when we're accessing this Cloud Run service. So let's do that. So here is the simple gcloud command to print the identity token, and we're storing that into the environment variable here for later use. Now in the next step, we're going to connect this with Gemini CLI. For that, we're going to open the settings.json of the Gemini CLI, and we're going to add the MCP server details to that. Now since I'm using the Cloud Shell environment here, it comes with the Gemini CLI pre-installed. We can see the version of the Gemini CLI that is installed. Now let's proceed to editing the settings.json of Gemini CLI. We'll add our MCP server there. And now let's open the settings.json. It will usually be located in .gemini folder. Now let's open that in the Cloud Shell editor. So if we go here in .gemini and settings.json, and now we're going to add our MCP server, and for that we'll use this configuration for defining our MCP server. So we're saying it's the currency converter MCP server. and the HTTP URL will get that from our Cloud Run service, and this is the endpoint that we're going to use. We'll simply replace this with our endpoint, and that's how it is. And the /MCP, that's the endpoint for the MCP server there that we're going to specify. And for adding the authorization headers, first of all, we'll need the token, and we already have created and saved that into the environment variable ID_token, and that's what is being used here for authorization. And that's it. So we saved this one, print that out here, and make sure everything is good. Okay, we are done configuring Gemini CLI. Now let's open it. Now here we can see that the Gemini CLI has been initialized. Now if you just do /MCP, we should see that the MCP servers have been listed out, and then we can now see the currency converter MCP server that we have defined in the settings.json earlier. We can see the name of the MCP server and the tools, the get exchange rate, which is exactly what is expected. That's what is being exposed by the MCP server that we have deployed on Cloud Run. Right now, let's do a simple test here. We know what's expected here. This tool is doing a simple currency conversion. So we can use a sample prompt like convert 100 USD to euros. And let's see. Now we can see it's calling the tool, and we're going to allow it, and it came back with a response, and that's what is expected. So as we've seen, Gemini CLI successfully picked up the ID token that we have saved into the environment variable, and it successfully made a request to our MCP server by submitting the token, and it got authenticated, and it successfully executed the tool and then came back with a response. If we go to the Cloud Run service that we have deployed and open the logs, we should find an entry related to the request we just made. Here we can see a tool call that has happened, get exchange rate, and this was the endpoint that the tool has called, the public currency API, and then that's the expected response, and we can clearly see all of that in the logs. Okay, so that concludes our demo here. And that's how we take an MCP server from a local script to a hosted solution, which is scalable and secured using Cloud Run. That's it for the session. See you next time. Thank you.